The Earth is about to welcome a new moon, a temporary visitor that's about to join our planet's gravitational embrace. This celestial body, unlike our well-known moon, is a tiny asteroid only 10 meters across. Named 2024 PT5, it will soon be drawn into Earth's gravitational field and become a mini-moon for a brief 56.6 days. Discovered on August 7 by a South African telescope from the Asteroid Terrestrial Impact Last Alert System, this small asteroid will engage in a close encounter with Earth's gravity on September 29, looping around before it eventually breaks free and continues its journey through space in late November. Temporary moons, like 2024 PT5, aren't exactly new to Earth. Smaller asteroids have periodically been captured by Earth's gravity, turning into short-lived companions before eventually moving on. However, this phenomenon remained largely unknown until recently. It was only in 2006 that astronomers first identified an object orbiting Earth, which stayed for about 9 months before escaping toward the Sun. This sparked debate among astronomers about whether Earth regularly captures such minimoons, a question that was resolved in 2012 through a University of Helsinki study, showing that at any given time, there's almost always a mini-moon of at least 1 meter in diameter orbiting Earth. Interestingly, Earth's gravitational capture of these tiny bodies poses minimal risk. The vast majority of minimoons, once caught in our orbit, follow a predictable pattern of being pulled into and out of Earth's gravitational grip without incident. Studies estimate that only about 0.1% of impacts on Earth's surface come from minimoons that were once orbiting companions. This means our new guest, 2024 PT5, is unlikely to pose any danger as it comes and goes. 2024 PT5 belongs to the Arjuna class of near-Earth asteroids, known for orbits that closely resemble Earth's, with low inclination and eccentricity, circling the Sun roughly once per year. This unique orbit means Arjuna asteroids frequently approach Earth, sometimes following our planet in a horseshoe orbit, periodically bringing them within a few million kilometers. In the case of 2024 PT5, it will orbit just outside the Hill sphere, around 1.5 million kilometers away, which is where Earth's gravitational pull is strongest relative to the Sun's influence. Despite the thrill of having a second moon, this new visitor will not be visible to the naked eye. At only 10 meters across, it's much too small and too distant to be seen without a telescope. However, even after it departs Earth's gravity, it will remain in the vicinity, and will come close again on January 9, 2025. Following this brief encounter, 2024 PT5 will journey away for a few decades but is expected to return to Earth's neighborhood in 2055. This mini-moon phenomenon sheds light on similar mysteries in our solar system. For instance, Mars, our planetary neighbor, has 2 small moons, Phobos and Deimos. Their odd shapes and unusual orbits have led scientists to speculate that they may have once been asteroids captured by Mars's gravity. Alternatively, Phobos might be a collection of debris from a massive asteroid impact on Mars, or even fragments from an ancient Martian moon that broke apart billions of years ago. Intriguingly, Earth has its own quasi-satellite, an asteroid named Kamalawa. At about 50 meters wide, it's roughly 5 times larger than 2024 PT5 and has been orbiting Earth for nearly a century, though it's not an official satellite. Kamalawa oscillates between a circular orbit around Earth and a horseshoe-shaped orbit, defying typical mini-moon patterns. Some researchers suspect it may actually be a lunar fragment that was once ejected from the Moon after an impact event, a hypothesis that was tested in a 2021 study. In 2021, researchers simulated scenarios in which fragments from the Moon could potentially enter Earth's orbit. They found that although most fragments are either too fast or too slow to achieve orbit, a small percentage could indeed end up as mini-moons. Those that do are likely ejected at slightly higher than escape velocity, creating a tenuous gravitational link that allows them to orbit Earth, much like Kamalawa. While the idea of moon fragments orbiting Earth sounds plausible, there are challenges. Most ejected fragments don't stay in orbit long. However, the simulations did reveal some fragments with orbits similar to Kamalawa's, suggesting it might indeed be a piece of the Moon. Though rare, the study confirmed that moon fragments could feasibly become Earth's temporary satellites, adding a fascinating twist to our understanding of celestial dynamics. This research has also reignited interest in the origins of our own moon. One theory proposes that a Mars-sized body collided with the young Earth, producing enough debris that eventually coalesced into the moon. This cataclysmic event would mean Earth and the moon share similar material origins, possibly including fragments that, on rare occasions, could be recaptured by Earth as quasi-satellites. Whether 2024 PT5 and Kamalawa turn out to be more than temporary celestial guests or hold clues to our moon's ancient origins, their orbits around Earth continue to intrigue scientists. Our understanding of celestial bodies, both near and far, will deepen as we learn more about these passing companions, each one a reminder of the dynamic dance between planets and asteroids in the vast cosmos. The Earth is set to gain a temporary new moon, an asteroid named 2024 PT5. Though it's much smaller than our familiar moon, at just 10 meters wide, this cosmic visitor will be captured by Earth's gravitational pull, making it a mini-moon for roughly 56.6 days. Discovered by a South African telescope on August 7, PT5 will drift into Earth's gravitational sphere on September 29, completing a unique, temporarily captured flyby, before heading back out into space in late November. This short visit gives astronomers a rare opportunity to study the behavior of objects caught in Earth's gravitational field. While the concept of a temporary moon may seem unusual, Earth has captured small asteroids in this way before. Smaller objects can occasionally get trapped by Earth's gravity, entering brief orbits before moving on. For a long time, astronomers weren't sure how often this occurred, but in 2006, researchers identified an object in Earth's orbit that stayed for about 9 months. Studies since then, including one by the University of Helsinki, have revealed that Earth almost always has at least one small companion asteroid in its orbit. These mini-moons are usually too small and distant to observe directly, but their temporary presence illustrates how Earth's gravity influences nearby space. Despite the thrill of another celestial body in Earth's orbit, 2024 PT5 won't pose any danger. Most mini-moons follow predictable paths and safely exit Earth's gravitational field without incident. Scientists estimate that only about 0.1% of Earth impacts have come from mini-moons, and none of these have caused any serious damage. This temporary guest, like others before it, will be a silent companion as it drifts through Earth's orbit before returning to a path around the Sun. Interestingly, PT5's journey resembles that of an asteroid class known as Arjuna asteroids. These asteroids orbit the Sun in paths that mirror Earth's, with low inclination and low eccentricity. Some, like PT5, follow Earth in what is known as a horseshoe orbit, making close approaches to Earth from time to time. Between September 29 and November 25, PT5 will come within 1.5 million kilometers of Earth, close enough to be influenced by Earth's gravitational Hill sphere, the zone where Earth's gravity dominates over the Sun's. However, even at this close range, PT5 will be invisible to the naked eye. Earth isn't the only planet with mysterious companions. Mars has 2 oddly shaped moons, Phobos and Deimos, which may also be captured asteroids. Some scientists theorize that these moons were once space rocks that Mars caught in its gravity. Others suggest Phobos could be a remnant of a past collision, possibly a field of debris from an asteroid impact that formed into a satellite. These mysteries around Phobos and Deimos highlight the intriguing, varied origins of planetary moons, reminding us how complex and unpredictable our solar system's history can be. Earth has its own long-term quasi-satellite, Kamalawa, an asteroid about 5 times larger than PT5. Unlike most mini-moons, which stay for only a few months, Kamalawa has been in a stable orbit for nearly a century. Researchers believe it may actually be a fragment of the moon, ejected by an impact event. A study in 2021 tested this theory by simulating the ejection of lunar fragments into Earth's orbit. The results showed that while most fragments would escape Earth's gravity, a small percentage could end up as mini-moons, entering orbits similar to Kamalawa's. This surprising finding hints that even Earth's ancient history could still influence the current makeup of its nearby space. These captivating interactions between Earth and nearby asteroids deepen our understanding of orbital dynamics and the ever-changing nature of our cosmic neighborhood. Temporary moons like 2024 PT5 and quasi-satellites like Kamiawa remind us that Earth's gravitational pull is more complex than it seems, constantly influencing and even capturing nearby objects. Each mini-moon is a new chapter in the story of Earth's gravitational relationship with surrounding celestial bodies, giving astronomers a unique opportunity to study how these chance encounters might echo throughout the solar system. As we learn more about these fleeting companions, they may help unravel similar mysteries surrounding moons and asteroids around other planets, expanding our knowledge of the vast, interconnected web of forces in our universe. Thanks for watching. Don't forget to like and subscribe to Space Lab for more space mysteries and discoveries. See you next time.